The last method we're going to cover here in the notes for solving quadratic equations is the quadratic formula. You should be very familiar with this, so here we have it written out. So we have x equals the opposite of b, so negative b, if you think about it as the opposite, plus or minus, and then we have our square root of b squared minus 4 times a times c. And then one important thing is this is all over 2 times a. That 2 times a is the denominator of the entire numerator. Sometimes I have students not draw their fraction line completely, and then they end up with the wrong answer. So make sure that denominator is underneath the entire numerator. We know our a, b, and c come from our standard form. So here's our standard form. We do have to make sure that our equation is set equal to 0 before we can use our a, b, and c values. And we also have a note here that a cannot be 0. And that's because if a is 0, this whole value would be 0 and we would no longer have a quadratic function. So we have our quadratic formula. We'll do a couple review of solving it. And the nice thing about the quadratic formula is that it works no matter what. You can use this to solve every single quadratic equation. Doesn't matter, as long as it's an x squared value, you can use the quadratic formula, which is nice because you can't factor everything. You can't necessarily use square roots for everything. And completing the square works for most things, but sometimes it can get kind of messy. So the quadratic formula is pretty basic and it works on everything. So let's start with letter A. First thing we need to do is we need it set equal to 0. It's not set equal to 0 here, so let's subtract the 9 over. So x squared plus 3x minus 9 equals 0. Now we're good to pick out our a, b, and c. So here our a value is 1, b is a positive 3, and c is a negative 9. Watch your positives and negatives here, please, as you're substituting in. And because this is something that you've done many times before, we tend to kind of rush through things if we're pretty comfortable with them. So we really want to make sure that we're paying attention to what our values are and we're copying everything down correctly. So we're going to have x equals the opposite of b, so negative 3, plus or minus a square root of b squared. Notice I use parentheses there. That's really important. Minus 4 times a times c, and then all over 2 times a. And from here, it's just simplifying. So let's go ahead and see what we come up with. So we get x equals negative 3 plus or minus. And then what I like to do is in your calculator, don't type in the square root yet. Just type in everything under the square root. So in your calculator, type in 3 squared minus 4 times 1 times negative 9 and put those parentheses exactly where you see them. Put parentheses around the 3, put parentheses around the 1 and the 9. And then if you add those together, we're going to get 45. So that's the number that goes underneath your square root because we end up with 9 plus 36. All right, and then that's all over 2 times 1, which is 2. Now here, we can't take negative 3 and divide it by 2. 45, let's think about, can we simplify? Is there a perfect square that divides into 45? And the answer is yes, 9, right? So 45 is 9 times 5. So 9 is a perfect square. So what that means then is we can rewrite this as our negative 3 plus or minus, and then we can do 3 because the square root of 9 is 3, root 5 all over 2. Now at this step, we want to look and see, can I simplify between 3, 3, and 2? And I cannot, so that just tells me that I am done at this step here. So leave that square root in your answer. If there's a square root, leave it. Like I said in the other ones, if we had to graph this, we would want to figure out what the decimal is. Otherwise, we want to leave these exact answers. So there's our answer for letter A. Now with the quadratic formula, there's a special name for the number that's underneath the square root. When you do your b squared minus 4 times a times c, that value, the quantity under the radical sign, so under the square root, is called the discriminant. Okay? And the discriminant gives us some information in terms of how many solutions we have. Okay? So it says down here, it can be used to determine the number of real solutions of a quadratic equation. Well, how does that work? Let's take a look at the box that we have here. Okay. So if you have your quadratic equation here, so if we have our standard form and we find the discriminant, b squared minus 4ac, if we figure out what that number is. So in our first example, that number was 45. From what number was that up there? Example 6, this example right here, the number under our square root was 45. So this is from number 6. So our b squared minus 4ac was 45. And so if I look at my categories here, my categories are, it's either positive, 0, or negative. Well, mine is positive, right? 45 is positive. So that means that the quadratic equation has two distinct real solutions, and the graph has two x-intercepts, which means it crosses the x-axis at 2 points. If your discriminant, if you calculate and your discriminant is 0, that's our next option here, then there's one real solution, one repeated, which means it shows up twice, but it's the same number, and there's one x-intercept. And then if you figure out that number and it's negative, that means there's no real solutions. There are complex solutions, which we will talk about later. Those are those imaginary numbers, and the graph has no x-intercepts. So the number under the square root, the discriminant, the b squared minus 4ac, tells us if we have two solutions, one solution, or no real solutions. And that's based off of if it is positive, 0, or negative. So one thing your homework will ask you to do is determine the number of solutions. So to do that, all we have to do is do b squared minus 4ac. We don't have to do the entire quadratic formula. So in our case, this is the same problem. It looks like our a value is 1, our b value is 3, our c value is negative 9. So if we do 3 squared minus 4 times 1 times 3, times negative 9. Okay, that's 9 plus 36, which is 45. So this is the same as what we did. So because this is 45, because it's positive, we have two real solutions. And the problem asks us, determine the number of solutions. And so our answer is 2. So we can use the discriminant just to kind of get a heads up on how many answers we should get. All right, and then one more application to finish up notes here is, actually, we're not even doing an application, I'm sorry. We're just going to talk about the different applications and then where to reference them in your textbook. So more applications for quadratics is we can figure out the height of an object on the Earth's surface. And that is always using this general formula. And basically what this formula is for is like because of gravity, what goes up must come down. And so think about like if you are golfing and you hit a golf ball and it goes up and eventually it comes down, that's the kind of problem this is. So the height of an object. So we can figure out at what point does the golf ball reach its maximum, or how long does it take to reach and hit the ground, that kind of thing. So if we look at the formula, the S is representing the height. The V naught, we call this, V sub 0, V naught is the initial velocity. And then the S naught, or S sub 0, represents the initial height. So the starting velocity, the starting height, and then T represents time. So you will see if you look at example 8 in the textbook, there's an example for that equation. You can also use quadratics to model change over time. So as time goes on, how does a value change? How does the position change? And that, if you look in the textbook, is example 9. And the Pythagorean theorem, which you worked a ton with in geometry, is another squared, that a squared plus b squared equals c squared. So that is an example of quadratic because they're all squared, and that's example 10 in your textbook. So you will want to check those out as you work on your homework. And here is your homework on page 110. These are chunked apart, so make sure you copy all these chunks down correctly, but you are only doing odd problems, so you can check your answers in the back of your books. And as always, please let me know if you do have any questions.